back on the class of soil and rock mechanics. I hope you all are healthy and good. So in the last class I have discussed about some problems related to Rankine's earth pressure theory, and after that I have done some problems related to Russell and Bell theories, means application of cohesion and angle of internal friction in the Rankine earth pressure. So today I am going to discuss about Coulomb's wave theory. So what is the application of Coulomb's theory, what is the assumption, various assumptions taken by Coulomb's, and how to compute the value of active and passive earth pressure with the help of Coulomb's wave theory. So firstly we have to understand the various assumptions taken by the Coulomb's. So the first assumptions first, soil is homogeneous, isotropic, elastic, semi-infinite, dry, and cohesionless. So the first assumption is soil is homogeneous, isotropic, elastic, semi-infinite, dry, and cohesionless. Second assumption, the face of the wall in contact with backfill is vertical or inclined, and it is rough. So the first assumption is same as the Rankine. Soil is homogeneous, isotropic, dry, and cohesionless. But the second assumption, Coulomb's has taken the face of the wall in contact with backfill is either vertical or inclined and is rough. But Rankine has taken the face of the wall in contact with backfill is vertical. So this is the major difference between the Rankines and Coulomb. Third assumption, the failure wedge acts as a rigid body and stress over it are uniformly distributed. Third assumption is the failure wedge. So the back face of the wall, so we have seen the failure wedge. So entire failure wedge acts as a rigid body and stress over it are uniformly distributed. Fourth assumption, the failure is essentially two-dimensional and the rupture surface is planar and passes through heel of the wall. The failure surface is essentially two-dimensional and rupture surface is planar and passes through the heel of the wall. So the failure surface passes through the heel of the wall. And the fifth assumption, the location and direction of resultant thrust between wall and soil is known. The location and direction of resultant thrust between wall and soil is known. So the location means the active earth pressure or passive earth pressure acts at a distance of h/3, that is known, but the magnitude is unknown. So this is the another assumption taken by the Coulomb's. The point of application is taken of the lower third point of the wall by assuming triangular distribution by assuming triangular distribution of earth pressure. So what I told, the position and location means for the triangular distribution we know the earth pressure acts at a distance of h by 3 from base of the wall. So this is known. Sixth assumption, wedge failure is considered which is under equilibrium of three forces. Wedge failure is considered which is under equilibrium of three forces. What are the various three forces? The one is reaction, and another is lateral thrust, and the third one is weight of wedge. So these three forces are in equilibrium. 7. Self weight of wedge vertically downward. Self weight of wedge acts vertically downward. The resultant soil reaction capital R acts at downward angle of phi with normal to slip plane. And the last assumption, resultant thrust PA or PP between wall and soil acts downward angle delta with normal to the inclined face of the wall. So these are the various assumptions taken by the Coulombs. So let us take a retaining wall. So with the help of this we can easily understand these 10 assumptions. So I have taken a retaining wall. The inclination of ground surface at an angle of beta, face of the wall with the vertical at an angle of theta, and let us take this is the failure surface or slip plane. So it will act an angle of delta with the horizontal. This is the backfill. So this is wedge, and the weight of wedge, let us assume it is W, and in assumption it is taken the weight of wedge acts vertically downward. If this is reaction, R makes an angle of phi this is phi. So what is this angle? What is this angle? So if this is lambda, so this is 90 degrees, so this one is 90 minus lambda, so this angle is total angle is 90 degree. So total angle, so this angle is 90 minus 90 minus lambda minus phi. So it is coming lambda minus phi. So this angle with the normal, the reaction is acting at an angle of lambda minus phi. Similarly, active or passive thrust is act at an angle of delta with the normal, where delta is the wall friction angle. So if this angle is theta, so let us take a horizontal line. So if this is 90 degrees, so this angle is 90 minus theta. If this angle is 90 minus theta, so what is the angle of the normal with the horizontal is? So this angle is also theta. So with the normal, this angle is 90 minus theta minus delta, and this is the magnitude of PA. So PA will act at an angle of delta. So if I draw a normal line, so this angle with the normal is 90 minus theta minus delta. So if I make a force triangle, before I start force triangle, let us understand this assumption. So wedge failure is considered which is under equilibrium. So this is called wedge. This is called slip line or failure surface. So self weight of the wedge is vertically downward. So entire self weight. So we can compute the weight, just area of this wedge into unit weight of the wedge is the weight. Resultant soil reaction. So this is resultant soil reaction. R acts at a downward an angle with the phi with the normal to the slip plane. Similarly, resultant thrust PA or PP between wall and soil, between this is wall and this is soil, act downward an angle of delta with the normal. So this is delta, act an angle of delta. So we can compute, if this is theta, so this angle is 90. So this angle is 90 minus theta. So if this is theta, once again it is theta. So this angle, total angle is 90 degree. So this angle is 90 minus theta minus delta. So with the vertical line, we have computed the value of PA. It is 90 minus theta minus delta. So if I draw a force triangle, so let us assume if this is W and PA, this is PA. So, and this is R. So the angle between W and R, it is angle how much? Lambda minus phi. Similarly, the angle between PA and R, we have computed W and PA, it is how much? 90 minus theta minus delta. So this angle we can compute. Let us assume this is X. So X is nothing but total sum of the triangle. Total angle in a triangle is 180 degrees. So 180 minus lambda minus phi minus 90 minus theta minus delta. So we can compute this angle. So once we compute this angle, so with the help of sine law, we have already computed W, wedge. Weight of wedge is nothing but the area of this wedge into unit weight of the soil. So weight of wedge is known. So we have to compute PA. So W by this angle X is equal to PA by lambda minus phi. So with the help of X is known, W is known, lambda minus phi is known. So we can compute the value of PA with the sine law. So firstly, let us denote all the symbols, where beta is the surcharge angle, theta is the angle made by vertical with inclined face of the wall. Delta is the angle of friction between wall and soil. Phi is the angle of internal friction. Angle of internal friction. So capital PA either we compute from sine law or 1 by 2 Ka gamma h square will act h by 3 from base of the wall, or according to sine law, so W divided by sine x degree is PA divided by sine lambda minus phi. So PA can be computed sine lambda minus phi into W divided by sine x. So we can compute from this or this. So once we solve this equation, so the value of active pressure should be minimum. So dPA by d theta should be minimum. So Ka can be computed sec theta into cos phi minus theta divided by square root of cos theta minus lambda plus square root of sine lambda plus phi into sine phi minus beta divided by cos beta minus theta. So once we solve this equation or differentiate, because active earth pressure or active earth thrust should be minimum, so the dPA by d theta should be 0. So once we solve, dPA by d theta is equal to 0, so we get the coefficient of active earth pressure. For a smooth wall, you have to take angle of wall friction is equal to 1/3 of angle of internal friction. For ordinary wall, delta is equal to 2/3 of phi. For rough wall, delta is equal to 3/4 times phi. So a special case, if theta is equal to 0, so what is, if theta is equal to 0, so the assumption is same as Rankine, means wall is vertical. Same assumption taken by Rankine. Second, if beta is equal to 0, means backfill is horizontal. And the third assumption, if delta is equal to phi, so Ka is equal to cos phi divided by square root of cos phi plus sin 2 phi into sin phi whole square. So here is also, we have not written total whole square. K is sec phi into cos phi minus theta divided by cos theta minus lambda plus sin delta plus phi into sin phi minus beta divided by cos beta minus phi, or entire to the power 2. if I write, this is K. For general case, once again you might write coefficient of active earth pressure. So it is coming sec theta into cos phi minus theta divided by square root of cos theta minus lambda plus square root of sine lambda plus phi into sine phi minus beta divided by cos beta minus theta and entire whole square. So this is the coefficient of active earth pressure. So I have discussed some special case when theta is equal to 0, so wall is vertical, so the same assumption taken by the Rankine. If beta is equal to 0, so backfill is horizontal. And the third case, if delta is equal to phi, so the active earth pressure coefficient is can be computed from this expression. So note. So in Coulomb's theory, failure wedge is assumed to be planar, but in actual it is spiral. It is spiral, especially in passive case. Hence, Coulomb's theory is not performed for passive earth pressure analysis. First note, Coulomb's theory, the assumption was the failure wedge is assumed to be planar, but in actual it is in spiral, especially in case of passive. So Coulomb's wedge theory is not performed for passive earth pressure. Second note, in Rankine theory, elemental failure is considered, whereas in Coulomb's theory, wedge failure is considered. So in Rankine theory, at any soil element it may fail, but in Coulomb's theory, entire wedge failure is considered. Third, Rankine theory face of wall is vertical and smooth, whereas in Coulomb's theory, face of wall may be vertical or inclined, and it is rough. So this is the major difference between the Rankines and Coulomb's. Rankine has assumed the face of the wall is vertical and smooth. There is no friction between the wall and the backfill. But this is not the actual case. The actual case is Coulomb's. In field, it is very difficult to make a retaining wall which is frictionless. So in the Coulomb's theory, the face of the wall is vertical, maybe vertical or inclined, and it is rough. So this is more realistic case as compared to the Rankine. And the fourth one, Fourth one, earth pressure can also be computed using Kalman's or Rebman's method. So these methods are graphical methods, which are graphical in nature. Fifth, Kalman's method is based on Coulomb's theory, which is modified version of Rankine theory. 6. With the help of friction circle method, we can also compute earth pressure. So these are the key points we have to remember. The first point was, in Coulomb's theory, failure wedge is assumed to be planar, but in actual it is spiral, and the spiral case is coming most of the in the passive case. That's why Coulomb's theory is not performed for the passive earth pressure. In Rankine theory, elemental failure is considered. The failure is at any point, but in Coulomb's theory, entire wedge will fail. Third point is, Rankine theory, face of the wall is vertical and smooth, but Coulomb's has taken the face of the wall may be inclined or vertical, but there is a friction between the wall and the backfill. Earth pressure can also be computed using Kalman's or Revan's method, which are graphical in nature. Kalman's method is based on the Coulomb's theory, which is modified version of Rankine theory. And with the help of friction circle method, we can also compute the earth pressure. So dear learner, today I have discussed about the Coulomb's wedge theory, and we have seen the various assumptions taken by the Coulomb's, and we have discussed how Coulomb's wedge theory is different from the Rankine's theory, and after that we have seen how to compute the value of active earth pressure with the help of Coulomb's wedge theory, and after that I have discussed some key points and some difference between the Coulomb's and wedge theory. So in the coming class I will discuss about the sheet pile wall. So in sheet pile wall we will see the different cases, like we have to compute the depth of embedment for granular soil, cohesive soil, and after that I will discuss approximate method to compute the depth of embedment for a cantilever sheet pile wall. So for more updates you can also visit my civil engineering blogs, talktorashid.blogspot.com. Happy learning.